Okay, so now we're going to move on to metals with more than one charge. These are going to be called multivalent metals, and they're a little bit different from metals with only one charge. So this is how we're going to work through them, okay? So metals with one charge, we had things like, remember we had things like magnesium, right, Mg2+, and chloride, Cl-. Okay, Mg2 plus, Cl minus, very easy, we just switch them, right, back and forth, MgCl2, that's what we got, all right? However, if you have this chart, which you will have on the test, know that the transition elements, transition metals, have more than one charge. So if, let's say we're looking, for example, at iron. Iron is Fe. So there's Fe2 plus or Fe3 plus. That's what we have, Fe2 plus or Fe3 plus. If I tell you, if I give you, for example, iron chloride, you have no idea whether that's Fe2 plus or Fe3 plus. With magnesium, it was easy. We just did magnesium chloride, Mg2 plus, Cl minus, boom, we got it. And remember, this is elemental chloride, the ion version of it. So it's just going to be chlorine, not chlorate, not anything else, just chloride, Cl minus. So iron chloride doesn't work out. So I need to tell you whether it's iron 2 chloride or iron 3 chloride. Otherwise, it doesn't work out. Remember that for the multivalent metals, specifically for these four right here, remember we skipped mercury, we're going to use the Latin name, and that can also tell us. So instead of saying iron 2 chloride or iron 3 chloride, I can say ferrous, ferrum, ferrous chloride. I can say ferric chloride, which is Fe3 plus, Cl minus, and then we make it to FeCl3. I can also say plumbus chloride, again, plus 2. Plumbic chloride, which will be PbCl4. Again, I'd cross the Pb4 plus with the Cl minus 1. I'd cross them, I'd get PbCl4. I can also have stannous chloride, again, SnCl2. Stannic chloride, SnCl4. Cuprum, CuCl. Cuprous is CuCl. Or I can have cupric chloride, Cu plus 2. And again, know these guys right here. This is called the classic system of naming. We use the Latin names. We use this base right here, and we match it up with either us or ic to denote the charge. Okay, so for example, for ferrous chloride, ferrous, remember it's OUS, so we're going to look at the lesser of the two. What's the lower charge on the ferrous ion? It's an Fe2 plus. What would ferric be? The upper charge, Fe3 plus. So let's say I give you ferrous chloride, it's just Fe2 plus, Cl minus, that'll give us FeCl2. And we can see this over here. So which one would this be? We just said this would be ferrous chloride. Remember, we start off with an Fe2 plus, go to have a Cl minus 1, switch them, get FeCl2. Ferric chloride would be FeCl3, Fe3 plus, Cl minus 1, switch them, get FeCl3. What if I gave you, what if I gave it to you backwards, okay? What if instead of saying iron 3 chloride, I just wrote, for example, what if instead of just doing FeCl3, what if I just did this, okay? FeCl3. How would you know what charge the iron has? Well, for here, it's a little bit simpler. You're saying to yourself, okay, this is a 1, so it's very simple. It's going to be a 3, okay? But that's not always the case. So even though this is originally Fe3 plus and Cl minus, and we can sort of do that pretty easily in our heads, it's not always going to be that easy. So for example, if I gave you, for example, Fe2O3, a lot of you guys would see the 2 and be tempted to say, oh, you know what? This is Fe2, so this is going to be ferrous oxide. That's not the case, okay? We're going to do a little bit of reverse work over here. We're going to say that because this is a 2, and because this is a 3, originally this was Fe3 plus, and this was O2 minus, okay? If that's the case, then this is ferric oxide. And where did I get the 2 minus for oxygen? It's, again, just the column that it's at. Remember, it's on the 6th column, so it's going to be a -2 charge. And be careful, things like nitrogen also. So if I had FeN, what would that be? That would also be ferric nitride. And remember, it's just nitrogen as an ion, nitride. Okay, that's pretty straightforward. What if I had zinc phosphide? Same concept. Okay, zinc has a charge of +2, so we're going to put a +2 here, Zn +2. Phosphide, the ion of phosphorus, is going to have a -3 charge, Zn3P2. Again, this is all completely different if we use the polyatomic ions. I can say to you guys, all right, give me the formula for, let's say, zinc phosphate. And a lot of you guys will be stuck on the phosphide thing. You guys were right. Okay, well, phosphate P3 minus. That's not the case, okay? Whenever you have an 8, anything other than ID, if you notice the common theme here, everything was ID. If all of a sudden you have an 8 or an ite, that's a great hint that you have a polyatomic ion. So if I have zinc, I'm going to write zinc. Zinc has a 2+, so actually let me just do Zn2+. What charge? Well, first of all, what is phosphate? You guys should know this. It's PO4 3-. Switch the charges. We get Zn3 PO4 with a 2 around it. It's that simple. Okay, remember that if we have more than one polyatomic ion, we just put parentheses and we put the charge associated with it. All right, what if I had something like, let's do this one backwards, okay? What if I had PB3N2? What would that be? So if this was just, you know, your normal run-of-the-mill metal with one charge, you would write, let's say we had potassium, right? Let's say this was a K. Imagine this is a K. It would just be potassium nitride. That's how we name it. But since it's a metal with more than one charge, we're going to have to be specific with what charge we're using. So it's PB3N2. And let's think. Again, a lot of you guys would be tempted to say PB3 is the charge over here. But it's not. We have to do some little bit of reverse work, okay? So let's see what we have originally. Originally, we have an N3- and a PB something. PB can only exist as either a 4 or a 2. So which one do you think it's going to be? It's most likely going to be a 2+. Okay, so we're going to switch the charges, and that's what it did up here. PB 2+ and 3-, and it's going to be lead to nitride. Another way of saying this, lead is PB, so it's going to be plumbous nitride. And again, IDE nitride. Yep, just be careful of the IDE. A lot of people see the ATE phosphate and they think, oh, it's, you know, this is phosphorus. It's not. It's phosphate. And that's it for ionic naming.